Have you ever wondered how a plane regains the trust of millions after a crisis that shook the entire aviation world? The Boeing 737 MAX saga is a story not just about engineering, but about trust, safety, and the relentless pursuit of improvement. For every aviation enthusiast, this story holds a special place. It's about how human ingenuity and technology combine to make the skies safer than ever before. Today, we're going to explore the Boeing 737 MAX 10 safety systems updated for 2026 and uncover why this aircraft represents a new chapter in aviation safety. The Boeing 737 MAX series was born from a demand for fuel efficiency, modern technology, and meeting the ever-growing needs of airlines worldwide. However, the early years of the MAX series, especially the MAX 8 and MAX 9, were marked by tragedy. Two fatal crashes, Lion Air Flight 610 and Ethiopian Airlines Flight 302, exposed critical flaws in the aircraft's Maneuvering Characteristics Augmentation System, or MCAS. This system was designed to prevent stalls, but errors in its design and implementation led to disastrous consequences. For many, it was a wake-up call. Even the most advanced airplanes are vulnerable. This crisis didn't just challenge Boeing's engineers. It shook public confidence and forced regulators, airlines, and manufacturers to rethink how safety is designed, tested, and maintained. The 737 MAX was grounded worldwide for nearly 2 years, a rare and sobering event in aviation history. But this grounding wasn't the end. It was a beginning. Boeing and aviation authorities around the globe worked intensively to address every safety concern raised by the crashes. Now, fast forward to 2026, and we see the Boeing 737 MAX 10 stepping into the spotlight. This model is the latest and largest variant of the MAX family. It's designed not only to serve longer routes and carry more passengers, but to embody the lessons learned from the past. For aviation lovers, understanding the safety systems on this plane means seeing how technology and human factors intertwine to create a new standard. Before we dive deep into the specific systems, it's important to understand why trust in an aircraft matters so much. Flying is, for many people, a leap of faith. The plane's ability to keep passengers safe depends on complex systems working perfectly under pressure. The human mind craves certainty and uncertainty. Aviation safety builds that certainty through layers of protection, continuous testing, and improvements informed by real-world experience. The 737 MAX 10 is a living example of this principle. If you're passionate about planes, you'll appreciate that every safety system on this aircraft has a purpose rooted in science and psychology. The redesign of MCAS, for instance, reflects an understanding of how pilots think and react during emergencies. It's not just about the hardware or software. It's about creating a relationship between humans and machines that's intuitive, reliable, and trustworthy. And here's the reward for watching this video all the way to the end. You'll gain a clear, detailed understanding of how the 737 MAX 10 safety features work together to prevent accidents. You'll discover how the latest advancements make flying not only possible, but safer than ever before. This knowledge will deepen your appreciation of aviation technology and give you a new perspective every time you board a flight. So, as we move forward in this video, keep in mind that what you're about to learn is more than just facts about an airplane. It's about the science of safety, the art of engineering, and the psychology behind trust in flight. The Boeing 737 MAX 10 doesn't just represent a plane. It represents a promise forged in adversity that flying can always get better. In the next section, we'll break down the core safety features of the 737 MAX 10. We'll explain how Boeing redesigned the MCAS system and added multiple layers of redundancy to ensure that the mistakes of the past are not repeated. You'll see how real-time diagnostics and pilot alerts work hand in hand to keep the flight crew informed and prepared. But first, it's worth reflecting on the sheer scale of the challenge Boeing faced. When millions of lives depend on a machine operating flawlessly in the skies, there's no room for error. Every component, every software line, every training manual must be scrutinized and perfected. This relentless attention to detail is why the aviation industry is one of the safest modes of travel in the world. In the case of the MAX 10, the story of safety is also a story of collaboration. Boeing didn't work in isolation. Airlines, regulators like the FAA and EASA, pilot groups, and independent experts all played critical roles in shaping the changes. This cooperative approach is part of why the 737 MAX 10 safety systems now meet the highest international standards. Understanding this background helps you see that the 737 MAX 10 is not just a product of engineering alone, it's a product of human determination to learn from mistakes and push the boundaries of what is possible. For aviation enthusiasts, this story resonates deeply because it reflects the spirit of the entire industry. always reaching higher, always safer. So stay with us as we uncover the advanced safety systems of the Boeing 737 MAX 10. The details you'll learn will enrich your knowledge and bring a new appreciation for what goes on behind the scenes every time this aircraft takes to the sky. Remember, flying is about more than speed or convenience. It's about trust, safety, and the invisible technology that protects every passenger. Let's continue this journey together. The sky is vast, and the future of flight is safer than ever. When we talk about the Boeing 737 MAX 10, it's not enough to know it's a big modern airplane. What truly matters to airplane lovers is how its safety systems have been engineered to protect lives at every moment in flight. The core of this safety lies in several interconnected features that work silently yet powerfully behind the scenes, constantly watching, checking, and adjusting. One of the most important systems on the MAX 10 is the Maneuvering Characteristics Augmentation System, or MCAS. Many people remember MCAS from the earlier MAX 8 and MAX 9 models because of the tragic accidents that brought it to the world's attention. But the MCAS on the MAX 10 is not the same system. It has been completely redesigned and enhanced to prevent the failures of the past. This is no small feat. It shows how engineers took deep lessons from those incidents and transformed them into stronger, smarter technology. At the heart of this redesign is the addition of dual sensor input. Earlier versions of MCAS relied on data from just one angle of attack sensor, which measures the wing's angle against the airflow. If that sensor gave faulty information, the system could push the plane's nose down unnecessarily. Exactly what happened in the past crashes. Now, the 737 MAX 10's MCAS requires agreement from two separate sensors before it activates. This redundancy makes false activations almost impossible. It's like having two independent sets of eyes, both needing to agree before taking action. This simple but powerful change reduces the risk of errors drastically. Beyond MCAS, the 737 MAX 10 uses a layered approach called flight control redundancy. Think of it as multiple safety nets stacked one after the other. If one system fails, another is ready to take over immediately. This includes mechanical backups, electronic backups, and software backups. Together, they create three independent layers of protection. So, even in rare cases when a component doesn't work as expected, the plane can still be controlled safely by the pilots or automated systems. Another impressive feature is the aircraft's real-time software diagnostics. The plane's onboard computers continuously monitor the health of critical systems, including sensors, actuators, and flight controls. If any anomaly is detected, the system immediately alerts the pilots with clear, unambiguous warnings. These alerts are designed with human psychology in mind, helping pilots stay focused without feeling overwhelmed by unnecessary alarms. This is crucial because in high-stress situations, too many warnings can confuse or distract, increasing the chance of mistakes. These improvements are not just internal Boeing decisions. After the MAX crisis, regulatory agencies like the Federal Aviation Administration (FAA) in the United States and the European Union Aviation Safety Agency (EASA) demanded the highest levels of scrutiny. They introduced new certification standards specifically designed to prevent the kinds of failures that led to the MAX grounding. Boeing's safety systems on the MAX 10 meet or exceed these strict regulations, which have been updated to reflect the latest understanding of risks and human factors in aviation. In the cockpit, the pilot alert systems have also been redesigned for clarity and efficiency. The previous setup sometimes resulted in excessive or confusing alerts. Now, cockpit warnings prioritize the most critical information first, reducing the cognitive load on pilots. This means pilots can make quicker, better decisions when every second counts. Aviation psychology research has shown that clear and concise alerts help reduce stress and improve performance under pressure. Exactly what the MAX 10's cockpit design aims to achieve. All these safety features tie together with another key principle: transparency. The MAX 10's systems are designed so pilots always know what the aircraft is doing and why. This builds trust between human and machine. The plane never takes control away suddenly or without explanation. Instead, it acts as a partner, assisting pilots while leaving ultimate control in their hands. This balance respects the experience and skills of the flight crew, while also offering powerful safety nets. Moreover, Boeing's software development process for the MAX 10 reflects lessons learned from software failures worldwide, not just in aviation. It follows strict industry best practices, including multiple independent code reviews, rigorous testing under countless simulated conditions, and continuous updates even after the aircraft enters service. This continuous improvement cycle is vital, as it ensures the safety systems adapt to new challenges and technologies over time. In addition to technical changes, the MAX 10 safety is supported by extensive pilot training enhancements. Pilots now receive updated training that covers the new MCAS system and all revised safety features in detail. Simulator sessions expose them to rare but possible scenarios, helping build muscle memory and quick reactions. This focus on training reflects a deep understanding of human psychology, how pilots think, learn, and respond in emergencies. The goal is to reduce reaction time and increase confidence, making sure pilots are fully prepared to manage the aircraft safely in any situation. Overall, the Boeing 737 MAX 10 safety systems represent a shift from reactive to predictive safety. Instead of waiting for problems to occur, the plane's design anticipates possible failures and prevents them before they can affect flight. This approach uses advanced sensors, real-time data analysis, and layered backup systems to catch issues early. It's like having a vigilant guardian watching over every detail of the flight, day and night. For those who love airplanes, this kind of engineering precision and human-centered design is thrilling. It's a testament to how aviation continues to push the boundaries of safety. The MAX 10 doesn't just meet today's standards, it sets new ones. It shows how an aircraft can be powerful and efficient, yet still prioritize passenger safety above all else. When you fly on a 737 MAX 10, you're not just boarding a plane, you're trusting a complex system built on millions of hours of research, testing, and real-world feedback. The safety features embedded in every inch of the aircraft work quietly and effectively, often unseen but always active. This invisible shield protects every flight, giving passengers and pilots alike the confidence to soar higher and farther. Understanding these systems deepens our appreciation for the effort and expertise behind commercial aviation. It reminds us that safety is not a static goal, but a dynamic journey. The Boeing 737 MAX 10 stands as a shining example of this journey, a machine designed with care, insight, and respect for the lives it carries. Pilots are the heart and soul of every flight. No matter how advanced an aircraft's technology becomes, it's the human element that often makes the difference between safety and disaster. That's why the Boeing 737 MAX 10's design focuses heavily on human-centered principles, ensuring pilots are not just supported but empowered in every situation. One of the biggest lessons from the earlier MAX models was the importance of cockpit design that matches how pilots think and react. The cockpit is a place of intense focus and rapid decision-making. When emergencies arise, pilots rely on clear information presented in a way that doesn't overload their senses or cause confusion. Cognitive science shows that when information is too complex or contradictory, human performance drops sharply. The MAX 10's cockpit has been redesigned to minimize this risk. Everything inside the cockpit, from instrument layout to alert sounds, has been carefully calibrated to reduce stress and enhance clarity. Pilots now benefit from displays that prioritize the most critical data front and center, while secondary information is still accessible but doesn't distract. Alerts are designed to be intuitive, using clear language and distinct tones that help pilots quickly identify the problem and what action to take. This design respects the limits of human attention and memory, especially in high-pressure scenarios. Beyond cockpit ergonomics, pilot training has seen a radical upgrade since the MAX incidents. Training is no longer just about knowing procedures, it's about developing instinctive reactions. Airlines and Boeing have collaborated to introduce scenario-based training in full-motion simulators that recreate rare but dangerous situations in high detail. This allows pilots to experience and respond to system failures, sensor errors, and emergency maneuvers in a safe environment. Repeated exposure builds muscle memory so pilots can respond automatically and confidently in the real world. The training also emphasizes teamwork and communication. Flying a modern aircraft is a highly collaborative effort between the captain, first officer, and cabin crew. Simulators often include exercises that strengthen communication and decision-making under stress. This human factors approach is grounded in psychology research, recognizing that effective communication reduces errors and speeds up response times. Pilot unions and regulatory bodies have been active participants in shaping these training improvements. Their involvement ensures that changes aren't just technical but practical and pilot-friendly. This collaboration has helped restore trust between manufacturers, regulators, and the pilots who fly these aircraft every day. Muscle memory, clear UI design, and thorough training all work together to reduce reaction time when things go wrong. When seconds count, this combination can be the difference between a safe recovery and a critical failure. The human brain works best with predictable patterns and clear feedback, principles fully embraced in the MAX 10's cockpit systems. The MAX 10 also incorporates systems that directly assist pilots during emergencies without overriding their control. Automation supports, but does not replace, pilot decision-making. This balance is crucial because human intuition and experience remain invaluable. Instead of sudden automated actions that might surprise pilots, the aircraft offers gradual, understandable assistance that pilots can monitor and override if necessary. Another key consideration is how the design accounts for human error, which is inevitable. Aviation safety does not aim for perfection from humans, but rather builds systems that anticipate and mitigate mistakes. For example, if a pilot inputs a command that might cause instability, the flight control computers can gently correct or warn without taking full control. This soft intervention respects pilot authority while maintaining safety. The training and cockpit design are complemented by regular proficiency checks and updates. Airlines now include frequent refresher courses specifically on the MAX 10's unique features. This ongoing learning ensures pilots stay current with software updates, system changes, and best practices, reinforcing a culture of continuous improvement.
Psychology teaches us that confidence reduces errors.
When pilots trust their aircraft and their training, they perform better under pressure. The MAX 10's human-centered design fosters this trust by making systems transparent, predictable, and user-friendly. This is not just theory. It is supported by data from pilot feedback and simulator performance since the aircraft's reintroduction. Importantly, the 737 MAX 10's cockpit design reflects a global perspective. With airlines around the world flying this model, the systems are standardized to meet diverse regulatory environments and pilot backgrounds. This global harmonization simplifies training and reduces confusion for pilots moving between airlines or regions. In emergencies, this seamless integration of technology and human factors can save lives. For instance, if an angle of attack sensor detects a dangerous stall risk, the redesigned MCAS system now works in harmony with pilot inputs and alerts rather than working alone. Pilots receive timely information and can take immediate control if necessary, thanks to the clear communication and training they have received. The Boeing 737 MAX 10's human-centered approach exemplifies how aviation combines technology and psychology to enhance safety. It respects pilots as skilled professionals, providing them with the best tools and training to manage complex situations confidently.
This partnership between man and machine is a cornerstone of modern aviation safety.
For airplane enthusiasts, this focus on the human element reveals a deeper layer of what makes flying safe. It's not just about hardware and software, it's about understanding human behavior, limitations, and strengths. It's about building systems that support those who fly the planes, ensuring every takeoff and landing is as secure as possible. Every detail in the MAX 10's cockpit and training program has been designed with this philosophy. It's a powerful reminder that in aviation, safety is a shared responsibility between manufacturers, pilots, regulators, and even passengers. The 737 MAX 10 safety systems honor this by integrating cutting-edge technology with a profound respect for human skill and decision-making. This thoughtful balance between automation and human control is why the Boeing 737 MAX 10 is regarded as one of the safest aircraft in its category. It stands as a symbol of progress, showing how understanding human psychology can drive innovation in aviation safety, ultimately protecting lives and inspiring confidence in the skies.